Okay, we're doing a practice test for pre-calculus. And the first thing we have is write the interval that is described below in interval notation. So we're supposed to do is we're supposed to write this in interval notation, and then we can sketch this on a number line. And okay, I'm just gonna go and just do this. Well, one thing you could do is you could first do the number line, and that might be useful. And then come back and then use the interval notation. So I'm not using the graph paper that's given below, but okay. So let me just go ahead and put all the numbers here. The thing is, there's graph paper lying below this. I'm not using this. Oh well. Okay. It's not that bad though, my spacing. All right. So we're looking at all the points between 1 and 4. We're going to get those points. But also we're going to get 1. But we're not going to color in 4. That's not in our set. And when you write interval notation to express this, we write on the left, we always write the numbers from left to right. So on the left comes 1 and to the right comes 4. Now, as I already started, I wrote down the bracket on the left, which is the bracket that shows greater than or equal. You know, one little thing, which I don't know, I haven't heard anybody say this is so brilliant or anything, but you could make the square like into a little bit of an equal. Let's see, this is greater than equal, but the other one gets around like that circle because it doesn't include the 4. All right, so let's do this next one here. We have, this time I get to use the graph paper. So we're looking at all values of x less than 0, but not including 0. So I'll put an open circle around the 0. And again, I go from left to right, but it's a little bit funny that I'm doing the left to right. I'm going to do on the left, well, the right endpoint is certainly, no, I did it wrong. Sorry, not good, but I can fix it. I just think, okay, I'm going to make mistakes. Let's look for them and catch the mistakes. Sometimes I don't, but that's what I need to do. I need to look and catch the mistakes. Okay, on the far right is -1. What's on the left? Well, nothing's on the left, but the notation is to show it just keeps going on forever to the left is -infinity. But you'll put the left and the right. So you can, anyway, that's the notation. Infinity or -infinity, always get the round bracket. And then since we're not including -1, that gets a round bracket. Does anybody have any questions on that? Okay, now for the domain of the function, we start by finding things that are not in the domain. So what's not in the domain? Not in the domain. Well, we solve x squared minus x minus 6 equals 0. If I were really desperate, I would use the quadratic formula, but I find that myself and students are more likely to make mistakes. Factoring is, I think, by far the quickest way to do this if it's an easy factorization. I mean, some things don't even factor. And then I better double check to make sure I got that right. But x equals 3, x equals -2 are not in the domain. Why? Because plugging in x is 3 or -2 gives 0 in the denominator. And we can't divide by 0. So the domain of f is equal to all x such that x is not equal to 3, x is not equal to -2. When I have all real numbers excluding a point or 2 points, I don't want to use interval notation. Some people do, but I don't. I don't think it looks as good. Now, I think the way I wrote it looks the best. There's other ways to write it, but I don't think interval notation looks that good for this particular type of answer. For this next one, for the domain, I need 2 minus x to be greater than or equal to 0. Greater or equal to 0. Why? Because it's actually, I'm going to write it a little differently. I'm going to put 0 less than or equal to 2 minus x. And it's the same thing, but I wrote it differently. So what can I say about that? We're not going to take a square root of a negative number. So it's under the radical. When it's the square root, it has to be greater or equal to 0. And I can just add x to both sides. So I get x less than or equal to 2. Remember, for inequalities, if you do multiply or divide by negative, you flip the direction of the inequality. For this one here, I am going to use interval notation. I think it's convenient to use interval notation here. But you could use the set builder notation. It's all x such that x is less than or equal to 2. You can double check by putting in some numbers less than 2, like 0. 2 minus 0, you can take the square root. That works. It's not a perfect square, but you can put in negative 2 for x. 2 minus negative 2 is 4. Square root of 4 is 2. So you can check your answer to some extent by plugging in numbers in the interval that I just wrote down. Are there any questions about that?
So for the domain for that one, can we do, so we just write negative infinity 2, or we need to write it in the other notation?
No, either one's fine. Yeah, either one.
Okay, thanks.
Yeah, you shouldn't. I mean, some people, I'd probably even give you points if you just wrote x less than or equal to 2. But anyway, I think it should be either in set notation or interval notation. I mean, x less than or equal to 2 is a description of the domain. But when you put the squiggle bars, it's like dressing it up and making it look fancy. And this is a typo, but I think you sort of get the idea. It's supposed to look like this. So f of x is x squared if x is less than or equal to 0. 1 minus x if x is greater than 0. We're going to sketch the graph. Of course, there's a lot of other examples in the homework that you all did, and so you can go over that to get just more.
Did you post the homework answers already?
No, I want to do that this afternoon. I'm going to try to get my act together on that. So over on this region that I'm writing down, x less than or equal 0, that's to the left of the y-axis. You can see those x values are negative, can you? And then I'm going to write in some positive x values, x greater than 0. So for x less than or equal to 0, I have y equals x squared, and that's our parabola. What you could do is start by doing a dotted line parabola, but we don't want the whole parabola. This is just sort of a little technique for, as a beginning, put the dotted line there. And then, okay, I've been talking about for this y equals x squared, if I go to the left by 1, I go up by 1. Left by 2, up by 4, because 2 squared is 4. But I'm only going to bold or make dark or whatever you want to say, color in that part where x is less than or equal to 0. So I did the whole parabola just so I can get started on it, but I really only want the part where x is less than or equal to 0. Can I do it? Yeah, I could do it, but sort of. Okay, so I'm only going to do that part. X less than or equal to 0. Now I'm going to erase the rest of the parabola. It's gone now. And then the part where x is greater than 0, I have y equals 1 minus x, but that can also be written as negative x plus 1. So this is a line. M equals negative 1, b equals 1. So again, you can do more of the line as a starting point. Intercept is 1 slope was -1. I mean, you can plot points for lines too. You plot 2 points, throw in a third just to make sure. And if you have this y equals mx plus b form, it's easy to plot points. So that's the line. Oops, no, it isn't. I feel like maybe this program makes me a little lazy on this, but anyway, okay. So here's a line. However, I only want to color in the part greater than 0. And I don't want to include 0. So at 0, I'm going to put a round, a round circle. Oh, of course, the circle is round. I'm going to put a circle with nothing inside. That's what it's supposed to be like. I don't know. It's circles. Okay, there it's better. Okay. What do you say about that? What? That was weird. What happened? That was one of the weirdest things. Okay. Any questions about that? Sort of spent a long time on that. Okay, I'm gonna